Okay, I think yesterday we discussed the alternate series and the absolute convergent, conditionally convergent, and divergent, and how to apply this statement. So the next sections is about the ratio and root test. Okay. So how to start using this test or the method? Okay. So if you remember, let me write here, consider the geometric series that we have the A R with power of n minus 1, right? This is geometric series. So we know when the ratio is less equal 1, it will be converged, right? So at least ratio is, we get the ratio from the terms over the previous terms, right? Now the similar situations we can apply for what we call the ratio test. Okay, so we are going to use some ratio. So ratio test, let me write it here. Let me just describe what it is. Okay. So first, if we take limit as n getting larger of some ratio of an plus 1 over an, and this is equal to L. And if L is less than 1, then the sum or the series is, let me write, absolute convergence. Let me make it here. Is absolute convergent. Absolutely convergent. And then if, same thing, if L is greater than 1, then the series is divergent. And if the L is equal 1, what happens is we can say ratio test is inconclusive. Which means we need to use another method. We cannot make conclusion. So it's no conclusion. Okay, there is some statement for proving, but I think I will skip that part. But I hope the idea based on the geometric series makes sense for the ratio test. Okay. So as long as we can find the L, and we know the L as in some number, as long as it is not equal 1, then we could make conclusion it is convergent or divergent. Okay, directly. And it is one of the easiest tests, okay, the ratio test. You need just to find the ratio and then take the limit. And you will see, if we have time, I have some exercises that you will see directly what kind of series that has this ratio test. Okay? So immediately you can use, and then you can find converge or diverge. Of course, something that is related to when you immediately see any cancellation when you take these forms, then you can think, okay, I will use the ratio test. And the second one is the root test. So let me give you the two test method, okay? Because both of them, they are similar. So the first one is ratio. The second one is the root, okay? Okay, the root test is, as you maybe obviously observe, root means that if we have a series that has root, okay, or some component that can be taken by roots, okay. So if limit, so take by root of n of an with absolute value is equal L, and L is less than 1, then the series is, we can say, absolutely convergent, or perhaps just convergent, still okay. And then if L is now greater than 1, or if limit let me check first. Oh, maybe I forgot to mention the if limit is not exist. So this is also true for this one. So or if limit okay. Or maybe let me write completely limit then the series an is divergent. And then if limit this is equal 1, or this is equal 1, maybe this is just equal 1, I think it should be okay. Then the same result, that the root test is inconclusive. Okay, so both of these tests, they are having 3 consequences. Okay, so L less than 1, L greater 1 or infinity, or doesn't exist, or L equal 1. Okay, so only 3 possibilities. Okay, and for the root test, you see that this series is being taken by root with power of n. Okay, so for obvious reasons, any series that has maybe some power with some number or some number n, then you could directly write with this. Okay. So the power with well, it can be any numbers, or it can be any number of n, right? But of course, for some cases, the test can be used on one series simultaneously. For example, like you have the alternate series, and perhaps you can also test with the ratio test. And this also can be done. Okay? So there will be some sort of combination of tests that you might need to do. Okay? Maybe 2 or 3 tests for one series. Okay, maybe we could do some exercise to check. So next week you only have 2 classes, okay? The Monday morning with TA and Friday also with TA. So you have 1 week, 3-hour TA class. So I hope TA can give you more exercise for chapter 11, okay, from the sequence and then up until the ratio root test. Or if I can give you some introduction to the power series, but maybe just some introduction, not yet the details.
Professor, so next week, Friday morning, we're not gonna have, you're not teaching?
Yeah, only TA. TA will be in class. Okay. So Monday TA and then Friday also TA. Okay. Yeah. And so in the middle there's no class. Okay. No class on Wednesday and Thursday. Okay. Yeah.
When is the midterm?
Midterm will be around, I think, end of October. Around. Yeah. Okay, I think we can check some exercise. Maybe let's check this one. Okay. So question is determine whether series converge or diverge. I think we can start from number 12. If you look number 12, you could start from there. Okay, number 12 is, you can check that. Number 12, let me make a circle. The one that we might, maybe the number 14. And what else? Maybe number 17. Okay, let's start with number 12. Okay. So suppose you have this in the formula. Okay? You have n with power something, and then at the bottom side you have a constant with a power of n plus 1. Okay? Remember, whenever you have anything that related to factorial, to some power, okay, like this, my humble suggestion is just think about ratio test. Think about ratio test. Because ratio is about we multiply with something. So of course the result of the series will be having some powers or some multiplication which can be taken care by this factorial or the power. Okay? So you can immediately check the ratio test. It's not always work, but mostly it will work. Mostly it will work. Okay? So you could take the ratio test. So how to take the ratio test is basically you are going to take the limit, okay, and take n as large as possible, right? And then take this ratio between an plus 1 over an. And suppose that our an is based on the question here. So n with power of 10 divided by negative 10 with power of n plus 1, right? So what is an plus 1 then? So an plus 1, we just plus 1 the n. So n become n plus 1 with power of 10, like that. And then this part here will be n plus 1, so n plus 2, okay? Or if you would like, you could directly write in terms of limit and change all an plus 1 an with this terms, okay? So we can write the limit so n plus 1 with power of 10 and then negative 10 n plus 2 and n plus n power 10, and then let me write this first. Okay, this absolute value means that we are only care about the ratio, okay? So we can rewrite this. And then negative 10 n plus 1 and sorry. Okay. Okay, now you need to do some algebra here. You need to do some simplification, and I hope you can still do is simplification. Okay, wait. Okay, so look here. Look this power 10. Okay, this and this. Okay, I can group that, right? I can write n plus 1 over n with power of 10. The same, right? Okay. And the next one is look on this negative 10. Okay, this 2 forms. I can write this negative 10 with power of n and then multiply with negative 10, right? And then the other one I can write negative 10 with power of n multiply with negative 10 with power of 2, okay? Now I can cancel this. And of course I can also cancel this with this. So we have 1 over negative 10. Or because of the absolute value, it will be 1 over 10, right? So don't forget the limit here. Take absolute value. Take absolute value. Maybe let me make a correction. Okay. So we have limit 1 over 10, or even 1 over 10 I can factor out, right? I can factor out, it's just a constant. So 1 over 10 limit of this. But I can write this, and we can change this become 1 plus 1 over n, which is equal to 1, right? Because 1 over n is 0. So we could say that we have 1 over 10. Okay, our ratio is 1 over 10. It means that it's less than 1. So let me write here, it's less than 1. So at the end here, the series, what is this series? I forgot. This series, you can write the whole thing, or maybe you can write this an is also okay, because you already defined what is an at the beginning. Is convergent or absolutely convergent. Okay, now numbers 14. Okay, number 14. So this is number 12. Okay, next is number 14 maybe here. Number 14, let me write the question here. So n factorial divided by n with power of n. Okay, now like I said before, this is another example that the series that you will test is going to be easy if you are using the ratio. Okay, so every time you see the power with n or with other number and it requires n, and also the factorial, try the ratio test. So try the ratio test means I will write directly using limit. Okay, I hope you don't mind. So I will write limit like this, and then take all the ratio inside. So an plus 1 divided by an. Okay, and then the an plus 1, I will directly write here, n plus 1 and then factorial divided by n plus 1 with power n plus 1. And I will directly multiply and then switch. So n power of n divided by n factorial. Okay. Okay, now you need to get used to the factorial line. So n plus 1 factorial. Okay, n plus 1 factorial. Let me make some notes here. So notes that n plus 1 factorial is n plus 1 and then multiply with n factorial. Okay. Now you write like really long, for example like n plus 2 factorial. You can start n plus 2, n plus 1, and then n factorial. Or if you want to write completely, you can write n and then write n minus 1, n minus 2, n minus 3, and so on. Okay. If you want to know, like maybe you could check with some number. Maybe try 5, 6, 7, and you will see that it's going to be fit with the system, right? So whenever you see this, okay, and this is, I think, most of the case will happen and will be likely to be asked. Usually this is what will happen in some exams or questions. So you will see the n plus 1 and a factorial, and then you see the n factorial. The obvious guess is from this part, we could exchange this with this, right? Which we can cancel this with this. Okay? And for most cases, for ratio tests, this will likely to be happening. Okay? So this is, I think, one clue for the ratio. So I think we can start to simplify this. Okay? We can canceling all this part. So n plus 1 and then n factorial. And then the bottom equation, I can write n plus 1 with power of n and then multiply n plus 1. And also the other side here is n power of n and then n factorial. Okay. Okay, and then cancel this part and then cancel this part. Okay. And then we get that we have this ratio n with power of n and then n plus 1 with power of n. Or we can write, maybe we can just write directly. This can be n over n plus 1 and with power of n. Now, what will happen here? What will happen is we're having this power of n. Right? So we need to take some definition. This is definition based on calculus 1, okay, if you remember. So this will be, let me write, I can write this in terms of 1 over n plus 1 over n with power of n. Okay, but we still haven't solved this yet. Let me give you some context. So context is you have limit, and then you have n plus 1. This is, if we write in another form, anyone remember what is this? What is equal? No? Okay, let me just give you the review. Okay, this is what we call the E. Okay, another definition using E. Okay, the Euler number. Okay. So this part here, we could write E. So this could be 1 over E by definition. And of course, E is 2.718 something. So this is also less than 1, right? So if this is also less than 1, which we could conclude that this will be absolutely convergent. So whenever you find this structure, this limit, you can just take definition that is equal to E. Okay, now let me take the other examples before the root test. Let me add some pages. So let's say we start with so this question is still the same. we need to check, determine, converge, or diverge. And also the other one, maybe 2 questions. And for obvious reasons, whenever you see power n, it's either ratio or roots. But if this happens like this, you can see diagonally it's one component and then with power n. Then you can just use root, okay? Directly roots. So remember, if you root this series, they are the same conclusions with the ratio test. So how to check is basically take the limit and we take the roots of n of the absolute an. So we take everything inside and we can write this as like that, right? So we take square root or take the roots and then put everything. So we can cancel the roots with the power n, and then we have limit, and because absolute value we have 2 over n, which is equal to 0, and it's a number that is less than 1. So you could also take this absolutely convergent. Okay, now similarly we can do the same thing with the second one. So we take the limit, we take the root of n, put everything inside, okay, and then the result is the power n will cancel, but we still have 2 with power of 5 and n with power of 5 and n plus 1 with power of 5, or we could just make a bracket with power of 5. And then 2 power of 5, it's 32. Let me write 32 here. Limit. This become n plus 1. Okay. And then we can write as 1 over n plus 1 over n power of 5. And we can still write this as 1 plus 1 over n with power of 5, which is equal 1. Okay, so we have 32. And of course 32 is bigger than 1. So we say that this will be divergent. Maybe to make it short, let me move this a little bit to here, move a bit here, a bit here. Okay, maybe before we continue, any questions first? Any questions? Okay. Okay. Maybe the next question that because all the tests, like from the divergence test, integral test, the comparison, the alternate series, what else? The ratio test and root test. How do we choose, right? How do we choose? So let me give you some point of view, and then I think that will be the end of our lecture today. Okay. So let's see some of the questions here that is having a little bit. So left and right, they have similar looking series, but they are actually different. But how do we check, okay, or how do we choose our method? Okay. So you could look first, or maybe you could take photos. But I think I'll put all the notes later on the Moodle. Okay, number 1A, I think pretty simple. That is the geometry with 1/5 as a ratio, right? So since it's 1/5 is less than 1, it's supposed to be converged. So we can directly get the converge or diverge based on the structure. Okay. So let me write on the right side how to make decision. Okay. So how to choose the test. The first is the easiest one is divergence test. It's called divergence test, not convergence test. Okay? Means that whenever we take limit, whenever it is not equal 0 or doesn't exist, then it's diverged. So we take limit, okay, just limit. And the second one, look at the structure of the series. One of the simplest one is either P series or geometric series. So the P series is something like this. And P will be important to know how it's going to be diverge or converge. So P greater 1 is converge, P less equal 1 will be diverge. And then geometric series, we have the AR n minus 1, then we have R less than 1 is converge, and R greater equal 1 is diverge. Okay. Then the third one, perhaps we can make some comparison. Okay, comparison. Comparison test. It has two methods, direct and limit comparison. What's the difference? The direct, we can compare the series with other series that is easiest to be concluded. Okay, so it means that this is comparing the series AN with another one, BN. Okay, aside from that, we have the alternate series. This is when we have this or we have n minus 1 bn. Okay. And what is the requirement? Bn plus 1 need to be decreased. And what else? The limit. The limit need to be equal to 0. Then we know that this will be converged for alternate series. Okay. And then root and ratio. How to use them? As we mentioned earlier before, anything involve factorial or power by n, we can use directly. Okay. And then the last is integral task. It's not really useful. Okay. But this is not like you need to follow all from 1 to 6. No, but I think you can try first the difference test. Okay. If still you don't get conclusions, you can see whether the series is in the simplest form like P series or geometric. Okay. Okay. If not, then look at the series. If it's already have like -1, then you could jump to the alternate series and just using this. Or if it's having a factorial or powered by n, you could try ratio or the root test. And then you could see if the series is a little bit complicated, but you could try to compare with others. Okay. If you try to compare and you could get easy conclusion, then just comparison test. I think between direct or limit comparison, I think limit comparison is more easy to solve. Okay? The direct one, sometimes the conclusion may be a little bit, as long as we make sure the series is greater or less than the other series that we compare, I think we should be okay. But if we are not sure if it is greater or less, then go to the limit comparison. Okay. Limit comparison means that we are going to limit and take the ratio between two series, and we need to make sure that it has a value. Okay. And if it has value, then if the limit the series that we are compare is diverse, then our answer will be diverse. If it is converged, our answer will be converged. Okay, it's a little bit having some conclusions like that. Okay, so yeah, that's it. I hope you can try this, and I hope your TA also can give you more exercise. And yeah, I think I will end up until here. Okay.